My name is Akila. Today I am going to explain about margin and multi-class classifier. What is classification? Classification is nothing but a supervised learning technique. This means the model learns from the label data. For example, if you have images of animals with the labels like cat or dog or horse, the model learns pattern from the each one. In this, we have mainly two classifications are there. First one is binary classification and the second one is multi-class classification. Binary classification is nothing but in this mainly we have two classes are there like a spam or not spam, and then multi-class. In this, more than two classes are we are used like recognizing the digits from 0 to 9, and then this is the bar graph of the margin and the multi-class. This bar graph compares the different classifier performing the per multi-class task. Each bar may represent accuracy or score for a different model. The taller the bar, the better the model is performing. And then what is margin? Margin is nothing but a distance between the decision boundary and the closest data point from the each class. And a larger margin means the model has more confidence in its decision. This is the diagram of the margin. For example, if you imagine two classes, and the two classes of the points say red or blue, the model draws a line between the two classes. The margin is the space or either side of the line. We want to this space to be a wide as a possible. And then importance of the margin. These are the main importance of margin. First one is maximizing the margin helps the reducing overfitting. And then second one is encouraging the model to be more robust to be new data. And third, the wider margin often leads to more confidence. Hard margin versus soft margin. Hard margin is nothing but a model tries to perfectly separate all data. That means no mistake allowed. Equals perfect separate, perfect separation. And then soft margin is nothing but a model allows a few mistakes for better flexibility. This is more practically for real world missing data. This is the diagram of the hard margin versus soft margin. This is the hard margin diagram. This is the soft margin diagram. On this diagram, hard margin shows all points cleanly separated by a wide gap, but this only work if there is a no noise in the data, and the soft margin allows a few points inside the margin or the wrong side of the boundary, which helps the model performs better on unseen data. And then margin visual representation. This is the visualization representation of the hard margin and the soft margin. On this on the diagram on left, you see the hard margin SPM. All points are correctly classified and the margin is clear. On the right, soft margin is there. A few points are that are allowed inside the margin. This allows the model to generalize in the better to new data. And then multi-class classification. Multi-class classification is nothing but handles the problems with a more than two possible outcomes. For example, a model that reads the handwritten digits must decide to whether the number 0 or 1 or 2 up to 9. That's the 10. Unlikely binary classification where there are only two possible results, multi-class models must take one correct choice from many options. Here it is the evolution matrix. Evolution matrix are there: accuracy, confusion matrix, precision, recall per class, F1 score. F1 score is nothing but an macro or micro weighted. Accuracy is nothing but Accuracy is nothing but how many predictions were correct overall. And then confusion matrix is nothing but a table showing the correct and incorrect guesses for the each classes. And then precision and recall. This tells us the how the model identifies the each class specifically. And then F1 score. F1 score is nothing but a balance between the precision and recall. This is the diagram of the multi-class classification. In this chart, we can see metric values for the each classes. For example, precision for a class 1 might be higher than class 2. This helps us to where the model is strong or weak. And and then one versus rest overall strategy. This is nothing but the one common approach for the multi-class classification is one versus rest. In this, we have to train the one class pair for each class, treating it is this class versus all the others. Here, here it is the diagram of the one versus rest overall strategy. Mm, in this, we have to predict the final result in this based on the which classifier is most content. In this diagram, we have mainly three classes that are three classes is there. First one is binary classifier one, and then binary classifier two, and then binary classifier three. And then one versus rest. One one versus rest is nothing but a strategy is a common technique used to extend the binary classification along to multi-class problems. The another method is the one versus one, where we train a class pair for every pair of classes. For n classes, we create the n of n minus 1 by 2 class class pairs. For four classes, that means six classifications. These diagrams would show the pairwise comparison. It works well for a small class numbers, but becomes complexity if classes are mainly. So these are the algorithms for multi-class classification. First, several algorithms are we are using the support multi-class classification. First one is support vector mission, and then decision tree and random forest, and then softmax logistic regression, and then k nearest neighbor, and then neural networks. In this, each has its own uses. For example, decision trees are easy to understand, while neural networks can handle every complex task. Um, and then advantages of margin and machine learning. Uh, Margin helps the model in many ways. First one is clear decision boundaries. And clear decision boundaries is nothing but a maximizing the margin leads to more confidence and then and then better generalization. To the new data, this is nothing but a large margin reduce the overfitting and improve the performance on unseen data or new data. And then robustness to new noise. This is nothing but in soft margin as support vector mission. In soft margin allows the some accuracy to predict the values like yes or no, and then good or high dimensional data. Good or good or high dimensional data is nothing but they performing the well when number of futures. And then here it is the here it is the final conclusion of the margin and the multi-class classification. In this, we have margin, especially in support vector missions, helps to defines how confidently the model separate the classes. Soft margin works better in noisy real-world data, and then multi-class classification allows us to solve more complex prediction problems. Choosing the right strategies and understanding the margin helps improving the model performance. Thank you.